Hello everyone, it's me again, your one and only tutor, DanielAryee10. Welcome back. Yes, today, join me in this wonderful tutorial and let me show you the science behind the management and allocation of petroleum resources by taking you through a deep dive into the world of intertemporal optimization of petroleum resources heavily applied in the exciting fields of both petroleum economics and petroleum engineering, thus more specifically in reservoir engineering, etc. Great! First of all, let me start by explaining the very concept of intertemporal optimization. Yes, what is it all about? Good. So intertemporal optimization in petroleum economics ensures that oil extraction is planned to maximize the total net present value of revenue over time. It's about balancing how much oil to extract now versus saving some for later period or future years. In other words, a non-renewable resource, like many other vital resources, must be managed in an optimal and very efficient way, such that the short and long-term goals of economic agents are always met by satisfying both the economic principle of equilibrium and the resource constraint or the extraction limit condition. Alright, let's look at how it may play out in a simple layman's perspective. For instance, assuming financially you have only $10,000 available to you now, as a rational economic agent you would always want to know as much as possible exactly how much to spend now in the present time as opposed to exactly how much to save or must be left to cater for future periods and other for you to be in equilibrium. Thus, for instance, whether to spend $2,000 now and save $8,000 or perhaps spend $4,000 now and save $6,000 for future use, in other words, taking or making the best optimal decision among several other alternatives. Great. In fact, your careful pondering, analysis, calculation and effort towards this objective is implicitly synonymous to engaging your thoughts and efforts in the realm of intertemporal optimization, where essentially you are seeking to allocate your financial resources possibly in the best and efficient way in order to maximize or optimize the total net present value of the marginal benefit or utility derived from those resources over time, thus ensuring that the derived marginal benefit remains equal across the time periods, yes, ensuring you remain in an equilibrium position as a rational economic agent at all times within the designated time horizon. Yes, this is what intertemporal optimization is all about. Indeed, more specifically, intertemporal optimization provides the mathematical tools to make such decision in an optimal and very efficient way. Meanwhile, at this point, I would want you to take note of the key mathematical formula heavily used in this endeavor. NPV equals sum of P minus C times QT slash open parenthesis 1 plus or close parenthesis to the power of T over T years. Or simply stated as NPV equals P1 minus C times Q1 plus P2 minus C times Q2 over open parenthesis 1 plus or close parenthesis to the power of 1 up to the required number of T years. So as usual, regarding interpretation, I can say that again in context, the intertemporal optimization formula above is tasked with an objective that seeks to maximize the total net present value of revenue based on the total petroleum reserves and other relevant factors in a global context, by seeking to allocate or split the extraction of the reserves in an optimally efficient and effective way given that global context. Alright, great, but here's the thing, at this point I want you to get this kicker. Thus, it will be equally important for you to understand the definitions and interpretations of all the variables involved in the above formula, including the mathematical constraints that validates it, in other words, what the formula actually means. Alright, so let me show you just that at this point. 1. The NPV means net present value, and specifically in this case it represents value derived and expressed in terms of profits. In some cases it could be utility, marginal benefit, etc. 2. Point equals S market price of the resource at a particular time period. CT equals S the cost of extraction at a particular time. QT equals quantity extracted at a particular time. I equals annual expected price increment. R equals the discount rate. T equals nth year confirmed. T equals total number of defined years. Besides, get this catch, if you take the price at a particular time and multiply it by the corresponding quantity, it gives you the revenue for that particular period. And if you add 1 to the discount rate, or you will get what is called the discount factor. Hence, if you take the associated cost per each quantity or barrel of oil extracted and multiply it by the total quantity extracted at that particular period, you will get the total cost. Hence, when you subtract this total cost from the revenue, you will get the profit. benefit, or utility of that resource, but it must be discounted by the discount factor 1 plus R in order to get the net present value, which would be further optimized through the application of differential calculus. Subjected to the constraints. In addition, here are two important constraints to consider. 1. The total quantity or amount of oil extracted must not exceed a particular figure, since their resource is considered to be limited. Thus, mathematically, each quantity extracted at each time period when combined together must not exceed the total reserved quantity of oil. Thus, Q1, Q2, up to Qt equals Qt, which is total quantity of oil reserves. 2. The amount to be extracted mathematically cannot be negative. Yes, either nothing should be extracted, thus zero quantity, or some quantity greater than zero must be extracted. This can define mathematically as Qt should be equal or greater than zero, or simply rewritten as Qt equals greater than or equal to zero. Thus Qt and LT less than 0 or Qt cannot be -1, and hence it's mathematically invalid in this context. Good. Okay, now that you have a fair understanding about the concept in this relaxed sense, let us now dive deeper into the details of its application by shifting our focus towards a more scientific and a mathematically rigorous approach in order to solidify your understanding and grasp of the concept. So to accomplish that objective, please stay attentive and very well attuned as I take you through the intertemporal optimization problem below. Thus, Intertemporal Optimization in Petroleum Economics and Engineering by DanielAryee, February 21, 2025. Question: Imagine a multilateral organization like OPEC has total oil reserves equivalent to 1,000 billion barrels and wants to maximize its total net present value revenue over the next 2 years based on these total oil reserves. The initial global market price of oil is $100, but expected to increase by 5% annually. The extraction cost per barrel is constant at $20. OPEC applies a discount rate of 3% per year. What should be the optimal extraction rate over the 2 years under the constraint condition or under the extraction limit in this global context? Good. So I will show you how to solve this problem using 3 broad approaches, namely the direct marginal benefit approach, a derivative approach. However, I will use 2 variant methods when it comes to this approach, under which I have specifically termed as a variant technique called strict derivative and flexible method. So essentially the derivative approach will constitute 2 sub-methods. Then finally we will settle on the third approach, which will be a unique blend of the first 2 approaches, and it will be relatively much more hefty and elaborate. Yes, it will again include a lot of layman's explanation as well, in order to deepen your understanding and make this tutorial more accessible. Okay, let's kick the ball rolling, but wait a minute. At this point it is important to proceed by stating the general formula and also define all important variables constituting it. Even though some of the approaches may not explicitly use the general formula, yet it may still rely a lot on relevant variables in this general formula during calculations. A typical example is the direct marginal benefit approach. Great, so find below a list of relevant variables in the general formula for the intertemporal optimization question above. Thus, useful or required information for all the 3 approaches. Key mathematical formula. NPV equals sum of the difference between each year's price and cost all into bracket multiplied by Qt, with the result being divided by 1 plus R all into bracket raised to the power T repeated approximately over 2 years span. Or simply rewritten as NPV equals sum of P minus C times Qt slash divided by open parenthesis 1 plus R close parenthesis to the power of T over 2 years. Alternatively, the formula can also be stated as NPV equals the net present value of revenue for year 1 plus net present value of revenue for year 2 adjusted appropriately by the discount factor. Or simply rewritten as NPV equals P1 minus C times Q1 plus P2 minus C times Q2 all over open parenthesis 1 plus R close parenthesis to the power of 1. Definition of key variables. 1. NPV, net present value of revenue. 2. Point, market price of the resource at a particular time period. 3. C, cost of extraction at a particular time. 4. I equals annual expected price increments. 5. R equals discount rate. 6. Qt, Q1, Q2, total quantity of oil reserved. 7. Q1 plus Q2 is greater than or equals 0, thus must be non-negative, and must be greater than or equal to 0. Next, note the following stated values for the identified key variables. Q1 refers to barrels extracted in year 1. Q2, barrels extracted in year 2. Whereas P1 equals $100, thus price per barrel in year 1. P2 equals 100 times 1 plus I, equivalent to 100 times 1.05, or simply written as 100 asterisk 1 plus I, sad face 100 by 1.05. Hence, P2 equals $105, thus price per barrel in year 2. C equals $20 is the cost per barrel and R equals 0.03 is the discount rate. I equals 0.05 is expected price increment. TR, total reserve, thus a 1,000 billion barrels of oil to be extracted. Constraints, thus. Total reserve, TR Q1 plus Q2 equals 1,000 billion barrels. Q1 plus Q2 should be greater than or equals 0. Again, for reinforcement purposes, get this quick interpretation of the immediate two constraints above. Thus this stated constraint, total reserve, TR, Q1 plus Q2 equals 1,000 billion barrels implies that the total extracted quantities cannot or must not exceed 1,000 billion barrels if oil. In other words, the sum of Q1 and Q2 must be equal to 1,000 billion barrels of oil. Finally, the second and last constraint, Q1 plus Q2 is greater than or equals 0. This indicates that the extracted barrels of oil cannot be negative. In other words, extracted quantities must be non-negative. Yes, it must be either greater than or equal to 0. Great, now you are equipped enough for the next rigorous details. So now let me walk you through a complete solution by starting with first approach. Yes, I will proceed in solving this question above by starting with the most concise and simplest approach called the direct marginal benefit approach. Alright, so this approach can mathematically be stated directly by balancing the ratios of the marginal benefits to the ratios of the extraction quantities. Thus, by extension, the marginal benefit for each period depends on the respective quantities Q1 and Q2. This is simply because optimal extraction occurs when marginal benefits are balanced or are in equilibrium across the two periods. In other words, to calculate the optimal rates, I will leverage simply on equilibrium relationship or balancing between the ratios of the marginal benefits of year 1 and 2 and the ratios of the optimal extraction quantities Q1 and Q2. Okay, let's get the ball rolling. So solution step 1, balance the ratios of marginal benefit to ratios of extracted quantities to calculate optimal extraction. Thus, MB1 over MB2 equals Q1 over Q2, call this equation 1. Or simply rewritten as MB1 slash MB2 equals Q1 slash Q2, call this equation 1. Next, solution step 2, substitute marginal benefits. Thus substitute MB1 equals P1 minus C and MB2 equals P2 minus C over 1 plus R into equation 1. This implies that we now have P1 minus C divided by P2 minus C divided by 1 plus R equals Q1 divided by Q2. Simply rewritten as P1 minus C divided by P2 minus C / 1 ton plus R equals Q1 slash Q2, call this equation 2. Next, at this point we can further simplify by substituting the prices and R as well. Solution step 3, substitute for P1 equals 100, P2 equals 105 and R equals 0.03 into equation 2. Implies that Q1 divided by Q2 equals 100 minus 20, all into bracket divided by open bracket. 105 minus 20 all into bracket divided by 1 plus 0.03, bracket closed. Simply rewritten as Q1 slash Q2 sad face 100 minus 20 over 105 minus 20 divided by 1 plus 0.03. This reduces to Q1 over Q2 equals 80 divided by 85 over 1.03 all into bracket. After mathematical manipulation, Q1 over Q2 equals 80 over 82.5242. And now after cross multiplication, Q1 equals 80/82.5242 multiplied by Q2 were simply rewritten as Q1 sad face 80/82.5242 times Q2. Call this equation 3. Next, solution step 4. By using the resource constraint condition, Q2 equals 1000 minus Q1. You can call this equation 4. Now substitute Q2 equals 1000 minus Q1 into equation 3. Thus now Q1 becomes 80 over 82.5242 multiplied by 1000 minus Q1. Or simply rewritten as Q1 equals 80/82.5242 times 1000 minus Q1. Implies that Q1 equals 0.9694126 times 1000 minus Q1 all into bracket. Hence after the expansion, Q1 equals 969.4126 minus 0.9694126 Q1. Now by rearrangement and simplification, we now have Q1 plus 0.9694126 Q1 equals 969.4126. Hence after summation we now have 1.96941 Q1 equals 969.4126. We find Q1 by dividing both sides of the above equation by 1.96941. Therefore Q1 equals 969.4126 over 1.96941. So with the final computation approximately Q1 equals 492.24. Next, solution step 5. Now we can safely proceed to find Q2 using equation 4. Yes, now substitute Q1 equals 492.24 into equation 4. This implies Q2 equals 1000 minus 492.24. Therefore after the final computation, Q2 equals 507.76. Great, next, let's roll on with some relevant interpretation and translations. Thus based on the results above, the optimal split ratio can be stated as split ratio, Q2 over Q1 equals 507.76 over 492.24 1.03 or 1 is to 0.9694 thus equivalent to 3. This confirms that indeed Q2 is about 3% larger than Q1, or you could also say it about 103% of that of Q1. Alternatively, the split ratio can also be stated as Q1/Q2 equals 492.24/507.76 0.97 and equivalent to 97%, meaning Q1 is about 97% of Q2 or 3% smaller than Q2. So indeed, the above values represents the optimal balance between Q1 and Q2. Hence in the final analysis, given the conversion ratio of 1 to 1 billion, the equivalent total oil reserves of 1,000 billion barrels translate into 1 trillion barrels of oil reserves, confirming the fact that indeed each barrel or every single unit in the total reserve is equivalent or represents 1 billion barrels. This implies that, once again by the conversion ratio of 1 to 1 billion or 1 to 1 times 10 to the power of 9, OPEC's optimal extraction quantities are as follows. Q1 equals 492.24 times 1 billion. After manipulation, Q1 equals 49,224,000,000 barrels of oil. Next, Q2 equals 507.76 times 1 billion. Thus after manipulation, Q2 equals 507.76,000,000 barrels of oil. Alright, next, let's get to the stating this figures in words. Thus Q1 can be stated in words as 492,240,000,000 barrels of oil or 492.24 billion barrels of oil. Similarly, Q2 can be stated as 507,760,000,000 barrels of oil or 507.76 billion barrels of oil. Alright, now, at this point, for assimilation purposes, it will be better to quickly express these optimal extraction quantities Q1 and Q2 in monetary terms, or better still profits, since the main objective of OPEC is to maximize profits based on the optimal extraction rates. Great, okay. So since the market prices for year 1 is given as $100 and that of year 2 also given as $105. Thus, based on the data or the information above, I will express or translate Q1 and Q2 into the following profit or net revenue breakdown. Thus, year 1 equals 492240000000 times 100. Hence, after manipulation, year 1's profit is $49,224 billion, or stated in an exponential notation or standard form as $4.9224 times 10 to the power of 13. This can equivalently be stated in words as $49.224 trillion. Yet alternatively, business-wise or in a business-friendly way, I can state as $49,224 billion. Good, next. So, year 2 equals 507760000000 times 105. Hence, after manipulation, year 2's profit is $53,314,800 million, or can be represented in an exponential notation or standard form as $5.33148 times 10 to the power of 13. This can equivalently be stated in words as $53.3148 trillion, or in a business-friendly way stated as $53,314,800 million. Great, so next, total profits calculation over 2 years. Thus, summation of profits for both year 1 and year 2. Hence, this calculated as $49,224 billion plus $53,314,800 million. So after adding up profits for year 1 and 2, total profits equals $102,538,800 million. Also stated in an exponential notation or standard form as $1.025388 times 10 to the power of 14. Better still, this can be stated in business-friendly way as $102,538,800 million, or $102.5388 trillion. So clearly, with this approach, in order to determine the optimal split between the extraction quantities under the constraint, we needed to balance the ratio of marginal benefits to the ratio of extraction quantities, Q1 and Q2. Yes, this produced Q1 equals 492240000000 and Q2 equals 507760000000. Represents the optimal split quantities of OPEC's total oil reserves over the 2 years, and by extension it can also be referred as the optimally balanced quantities due to the equilibration of marginal benefits ratios to ratios of extracted quantities under the discount factor. Wow, isn't that elegant? So finally, I have clearly walked you through a complete solution, yet very concise and a simple one compared to the other 2 broad approaches yet to be unfolded as we proceed through this exciting tutorials. Meanwhile, depending on your interest, you may choose to stick with only this approach because it is complete in its own right and answers the question above, yet for a much more deeper, holistic, versatile understanding and for increased expertise in the subject matter, I would encourage you to watch this exciting tutorials to the end, in order to unravel everything I provision for you in my wisdom towards helping you to derive the fullest benefits. Alright, wait a minute. Yes, before we continue to the next section. Once again, I am DanielAryee, always eager to bring you the best, captivating and most impactful tutorials, especially in this first quarter of 2025. Yes, I have produced a lot of fresh, exciting clips right from the previous month, January, up until this month of February, with more exciting ones yet to come. Hence, please don't forget to like, share and subscribe to my channel for more videos. As usual, I would want to remind you again, yes, please do well to watch the complementary tutorials on the 2 other broad approaches to fully grasp all that Segment 1 tutorials have to offer. However, that Segment 2 tutorials will be supplementary, yes, something like an appendix to Segment 1. Truly, I promise, it is insightful and exciting. Yes, you will surely love it. Wow, so up until this point, I know that I have given you an appreciable amount of knowledge on the subject matter regarding intertemporal optimization. Meanwhile, though it is quite enough, yet to augment your understanding, I would still encourage you to watch my supplementary tutorials, which explains into details very relevant nuances pertaining to the subject matter. Surely, I have well provisioned it meticulously and intentionally for reinforcement purposes. Yes, I have done that, just for you, my cherished learner or viewer. At this point, I would first of all say, Glory be to my God the Most High, regarding everything, thus making all of this possible. Besides, I would want to make a shout out and acknowledge certain key personalities that have motivated me in so many ways in producing this wonderful tutorials. Yes, I have drawn a lot of inspiration from 1. His Royal Highness, Mohammed bin Salman Al Saud, or MBS, ruler of the Great Kingdom of Saudi Arabia. 2. His Highness, Sheikh Mohammed bin Rashid Al Maktoum, Vice President, Prime Minister, and ruler of Dubai. 3. The Great King of Spain, His Majesty, King Felipe VI of Spain. 4. Crown Prince of Dubai, His Highness, Sheikh Hamdan bin Mohammed bin Rashid Al Maktoum, Fazza, Crown Prince of Dubai. 5. Crown Princess Mara, Sheikha Mara bin Mohammed bin Rashid Al Maktoum of Dubai. 6. Princess Leonor, Her Royal Highness, Princess Leonor of Spain. 7. King of Denmark, His Majesty, King Frederick X of Denmark. 8. Prince William of Britain, His Royal Highness, William, Prince of Wales. 9. His Royal Highness, Prince Daniel, Duke of Västergötland. 10. King of Morocco, His Majesty, King Mohammed VI of Morocco. 11. President of the UAE, His Highness, Sheikh Mohammed bin Zayed Al Nahyan, President of the United Arab Emirates. 12. President of Egypt, His Excellency, President Abdel Fattah el-Sisi of Egypt. 13. His Majesty, King Abdullah II of Jordan. 14. Sultan of Oman, His Majesty, Sultan Haytham bin Tariq of Oman. Yet, I cannot end this list without mentioning and acknowledging all my wives globally, especially those in the Saudi and Dubai kingdoms, yes, those I have been interacting frequently with, including all thrones, kingdoms and nations I am connected to. Once again, I am DanielAryee10. Thanks for watching, and please don't forget to like, share and subscribe to my channel at DTechnology4 for more exciting videos coming up. Oh, but wait a minute, I have a special message to my fathers, yes. With deep affection, respect, and admiration, I acknowledge King Abdulaziz bin Abdul Rahman Al Saud and King Sheikh Mohammed bin Rashid Al Maktoum as my great fathers. To such an extent, I even see them as my parents-in-law. Their visionary leadership and relentless efforts laid the foundation for the prosperity of the exemplary kingdoms of Saudi Arabia and the UAE, including Dubai. Their legacy of wisdom, foresight, and resilience continues to inspire generations, including myself. Once again, may God bless you all, especially in this sacred season of Ramadan. Assalamu alaikum wa rahmatullahi wa barakatuh, shukran, ameen. But please let me add this quick clarification or hints. Thus in the audio, I segmented the equations and the solutions into 4 segments. The idea was to break it down to the barest minimum for your understanding, whereas, in the complementary tutorial slides, I limited the number to only 3 equations to make it concise. Hence, for you my audio-visual learners, just bear in mind that equation 1 in the audio points to equation 1 on the visual slide perfectly, yet equation 2 in the audio also points to same equation 1 in the visual slide, since it is just the same equation simplified into 2 segments in the audio, for a better understanding. Besides, take note that equation 3 in the audio points to equation 2 in the slide, and finally equation 4 in the audio points to equation 3 in the slides, yet both the audio and visual tutorial slide are mathematically accurate, complete and independent in its own rights. In other words, if you prefer audio learning, then you can only stick with the audio and you will be just fine. On the other hand, if you are a visual learner, you could also just rely only on the tutorial slide I have provided and you will be well furnished, as it is also complete. However, if you are an audio-visual learner and prefers both, then I will counsel or encourage you to take the hints and clarification above into consideration since that allows for synchronization between the two styles of learning.